Today, we're diving into a really powerful part of Six Sigma, the 7 management and planning tools. Now remember, these are different from the 7 QC tools. QC tools are about measuring and analyzing data. The management tools, they're more about structuring messy problems, planning projects, and making sense of complexity. Think of them as the tools that help us untangle the spaghetti in our heads and on our whiteboards. And to make this real, we'll be using a coffee factory as a practical example for explaining these tools. So imagine you're running this factory and you're facing quality issues, delays, and new projects. How do you manage all that complexity? That's where these tools come in. Let's dive in. First up, the affinity diagram. Here's the situation. You call a meeting with your factory staff because delays are becoming a headache. You say, "All right, team, tell me why we're always behind schedule." Within 10 minutes, the whiteboard is full of sticky notes. Machines keep breaking down. Suppliers are late. Instructions are confusing. Too few staff on Mondays. The label printer jams all the time. And so on. Now, if you look at that board, it's chaos. Just a mess of ideas. That's where the affinity diagram helps. You start grouping similar issues together. All the sticky notes about machines are collected under production problems. And notes about suppliers are under supply chain or logistics problems. Notes about staff goes under employee concerns. And finally, the notes about instructions can go under customer feedback. Suddenly, instead of 50 random comments, you have 4 clear categories. Now it's easier to see what areas deserve attention. That's the magic of an affinity diagram. It turns noise into patterns. Okay, so now you've grouped the problems. But the next question is, which of these causes drives the others? That's where the interrelationship digraph comes in. Let's stick with our delay problem. We map factors like machine breakdowns, poor scheduling, late supplier deliveries, overtime fatigue. We draw arrows to show cause and effect. For example, late suppliers force poor scheduling. Poor scheduling creates overtime. Overtime leads to tired workers and mistakes. When we finish, we notice that poor scheduling has the most arrows going out of it. It's the big driver. This tool helps you see that instead of chasing every little problem, you should start with the one that drives the rest. Next, let's talk about the tree diagram. This is like breaking down a big, vague goal into a clear action plan. Let's say management sets a target. We want to cut coffee pack defects by half within 6 months. Sounds good, but it's vague. How do we actually do it? We start branching it out like a tree. At the first branch, we write reduce underfilled bags, and under that, we add more branches for our actions, which are, let's say, recalibrate filler, train operators, and check scales daily. For the second branch, we have improve sealing. And as actions, we can write replace sealing jaws and set preventive maintenance schedule. Finally, at the third branch, we add improve grind consistency, and for the actions branches, we add standardize grind setting and introduce daily sampling. Now for each action, we can branch it more for each execution step. Suddenly, this big fuzzy goal becomes a clear step-by-step plan. That's what a tree diagram does. It forces us to break the goal into bite-sized, doable tasks. Now, sometimes we need to see how different things are related to each other. That's where the matrix diagram comes in. Think of it like a relationship map. And to build it, we list, let's say, our main defects on vertical side of the matrix and our departments on the horizontal side. So, for example here, we write for the defects, underfilling, sealing problems, and labeling mistakes. As for the departments, we have production, maintenance, engineering, packaging, and quality control. Now we go through the defects one by one and try to identify the relationship between each defect and the departments. For example, the underfilling problem has to be related to production and maintenance department. And the sealing problem is related to production as well as the engineering department. Finally, the labeling mistakes must be related to the packaging department as well as the quality control department. Now a close look into this matrix and you can easily realize that production is involved in nearly every defect. That tells us production has the biggest role in fixing issues. Without a matrix, we might just blame the department we hear about the most. But with a matrix, it's objective. It's clear. Now, we can take that one step further with matrix data analysis. Instead of just showing which departments are connected to which problems, we measure the strength of those connections. For example, we rate the link between underfilling and maintenance as very strong, maybe an 8 out of 10. Production here might also matter, but a bit less, say 6 out of 10. And for the ceiling problem, production here is the main player. So I would give it 9 out of 10. The engineering department here plays a role, so let's give it 7 out of 10. As for the labeling mistake, I would give packaging 8, and the quality control 7. Now, when we add these weights into the matrix, we can prioritize. Instead of chasing every connection, we focus on the heaviest hitters first. It's basically a way to move from everything is connected to here's what really matters most.
All right, let's switch gears. Imagine you're about to launch a brand new premium coffee line. Exciting idea, right? But anyone who's managed a project knows this truth. Even the best plans can fall apart if you haven't prepared for the unexpected. That's exactly where the Process Decision Program Chart, the PDPC, comes in. Here's how it works. You start with your plan laid out in a simple tree. Design packaging, prepare marketing, set up distribution. Then you take it one step further and ask, for each activity, what could possibly go wrong? For example, packaging. Your supplier might miss a deadline, the artwork could be rejected, or printing costs may come in higher than expected. Marketing. The campaign may fail to reach your target demographic, or your messaging might be unclear once tested. Distribution. Delivery trucks could be delayed, a warehouse might run out of space, or products may get damaged in transit. Once you've identified these potential failure points, you list countermeasures, concrete actions you can take before things actually go wrong. Actions like securing a secondary packaging supplier as backup. Conduct small-scale focus groups to validate your marketing message. Or work with multiple logistics partners to reduce the risk of bottlenecks. And to add extra quality checks before shipping to reduce damage rates. By visualizing risks and preparing responses ahead of time, you're not just reacting, you're proactively protecting your project. That's the power of the PDPC. It turns what if into here's the plan if it happens. Now the last MP tool is the activity network diagram. Think of this as project scheduling with X-ray vision. Instead of just listing tasks, you map them out so you can see how they depend on each other. Let's go back to the premium coffee launch. Your major tasks might look like this: packaging design, blend testing and approval, marketing, production trial run, and distribution planning. Now the packaging design may take up to 2 weeks. The blend testing and approval will take 3 weeks to complete, and the marketing will cost you 4 weeks of work. The production trial run, 2 weeks, and the distribution planning 3 weeks. Some of these tasks can happen in parallel, while others have to follow a strict sequence. For example, packaging design must be complete before you run the marketing. Blend testing has to finish before you can finalize the production trial run. When you map all of this as a network, nodes for tasks, arrows showing dependencies, you uncover the critical path, which is the longest chain of dependent activities. This path determines the minimum amount of time needed to complete the entire project. Here's why this matters. If any task on the critical path gets delayed, the whole project slips. No exceptions. But tasks not on the critical path often have some wiggle room, what we call float or slack. This tool is essential for large, complex projects where timing is mission critical. Product launches, facility upgrades, system implementations, you name it. So, let's wrap this up. The 7 management and planning tools give you structure, clarity, and forward-thinking control. The affinity diagram organizes scattered ideas into themes. The interrelationship digraph shows cause and effect relationships. The tree diagram breaks big goals into actionable steps. The matrix diagram reveals how variables or teams connect. The matrix data analysis adds prioritization and weight to those relationships. the PDPC, anticipates risks and builds countermeasures, and the activity network diagram maps project flow and protects your timeline. Together, these tools help you plan smarter, collaborate better, and avoid surprises. Remember, the QC tools help you analyze data, but the MP tools help you organize people, ideas, and strategies. In real-world Six Sigma work, you'll need both to succeed.
If you found this video helpful, don't forget to give it a like and drop a comment below. We'd love to hear your thoughts or questions. And if you're into leveling up your skills with expert-led content, hit that subscribe button and turn on notifications. For full courses, downloadable assignments, and certifications, head over to Excedify.com. Start learning smarter today.